Okay, let's see people that are with us right now. Fichukwu, thank you for coming. Tamono Grace, Irunebere Claire. Okay, you're welcome. You're welcome. So me and my students want to start electrolysis. That's the topic for today. I don't know if you can see the two lines on the board. I want to use it as a margin. I can be able to see what I am writing. Mbanude Edward, you're here. Thank you for coming. Jessica, can you see the two lines on the board, please? Mary, you're welcome. Marcus, you are welcome. Okorafo, you're welcome. Okay, so double tap on your screen to give it a thumbs up. We want to start. We want to start. Marcus, you're welcome. I see you. Okay, you can see the two lines. Okay, so we can start. Grace, Tamono, you can see it. Now we can proceed. Good evening, everyone. Thank you for joining us. Today we are going to look at electrolysis. Electrolysis actually is a conduction of electricity through liquid. It is configured and it is called what? Electrolysis. In this topic, we want to see how liquid conduct electrolysis, conduct current. Okay, we want to see how liquid conducts current. So we're going by defining electrolysis and types of electrolytes and the rest and laws. Then we can lead us to calculation. Okay, all right. Jen, we just started. Chukwemeka, hi, thank you for coming. UK Plus, you're welcome. Okay, let's explain. Electrolysis is the chemical change in a liquid due to the flow of electric current through a liquid. What am I trying to say? There is a chemical change in a liquid when current flows, and that is the concept of what? Electrolysis. You want to know how liquid conducts electricity. Okay, that is the concept of this electrolysis. There are some liquid that are good and those liquid are called what? Electrolytes. So electrolytes are good conductor of electricity, while liquid that are poor conductor of electricity are called what? Non-electrolytes. Let me do a recap. Electrolysis is the chemical change in a liquid due to the flow of electric current. Through the flow of electric current through the liquid, okay? Some liquids are good conductor of electricity and they are classified under electrolytes, while liquid that are poor conductor of electricity are classified under what? Non-electrolytes. So I'm going to look at the parameters or terms used in electrolysis. Amanda, I cite you. Ezocha, you are here. Make sure you are copying your notes because I'm going to be giving you classwork to do right now as you progress. If you have not subscribed to this channel, make sure you subscribe now. And make sure you double tap on the screen to like this class. Are we done writing so I can proceed? Firi, you're welcome. So we can proceed. We are done writing. Not done. And I've cleaned it. Okay, next time just indicate fast because I waited for a while. All right, let's go to So I'm using describing electrolysis, number one. Okay, Bello, Jane, I'm waiting for you. I want to explain before I clean, so write fast. Jane, are you done? Ezacha, you are done, okay? Osapo Okechukwu, you are done, okay? Kalio, you are done, all right? Banode Edward, you are done, okay? Maria Okorafo, you are done. So let me go on to explain. Tabono Grace, you are done. Amanda, you are done. Okay, let me explain. Now we are looking at the terms used in describing this electrolysis. Number one is electrolyte. Electrolyte is a liquid or molten substance which conducts a current and is decomposed by it. What do I mean? This molten substance conducts a current and is decomposed by what? By it. It must be in molten substance. It must be a liquid or molten. For a substance to be an electrolyte, it must be either a liquid or be in molten form. And molten form means semi what? Semi-liquid. It's not liquid, is not solid. So it's semi-liquid. And it must conduct a current and decompose in the process. Now we have some examples of liquid that can be classified as electrolyte. Example, we have liquids such as solutions of acid, bases, and salt are known as electrolyte. Now, what do I mean? If I say solutions of acid, bases, and salt, in an external exam, they can't tell you solutions of acid, bases, and salt. No. What they are going to do is for them to just give you an example. For example, they might tell you grape juice. Is grape juice an electrolyte? Yes, because this is what? An acid. It's a solution of what? An acid. So that is how they can ask you such question. Okay? Now, bases and salt. Any solution of it is what? Classified as electrolyte. They are non-electrolyte. We have benzene, paraffin. They are non-electrolyte. Then you quote, all organic compounds are generally non-electrolyte. If I say organic compound, I mean, you know, all the compound in organic chemistry, that is classified as organic compound. They are generally non-electrolyte. For example, sugar solution is an electrolyte. Kerosene is an electrolyte, okay? Kerosene is an electrolyte. So any alcohol is an electrolyte. So any compound that is gotten from organic chemistry, let me say organic chemistry, organic compound, they are generally non-electrolytes. Do we understand? So they are generally what? Non-electrolytes. So you should not forget that electrolytes are classified into two: electrolyte and what? Non-electrolyte. Now, electrolyte allows current to pass through them, but non-electrolyte, they are the poor conductor of electricity. So most time we don't use non-electrolyte in electrolysis. Is that okay? All right, so let's look at other terms used in describing electrolysis. Some log grade say it's boring. Can you check your network? Jane, we are done. Lucky, you are done. All right, so we can proceed. We can proceed, right? Okay. Chika, we are done. All right. Chukwemeka, you are done. Okay. Okay, please, if you are just joining us, just like this live stream, just like it or double tap on your screen. Okay, that means you are with us. Thank you so much. Let's go to number 2. So I can do it now. Bridget Igwe, you're welcome. Obunaya Godwin. My omitted which under anode is a positive electrode. Thank you for that. Through which, okay, current enters the electrolyte. Thank you, Obunaya Godwin, for the observation. That means we are together. All right. Can write fast so I can explain. We have a lot of work to do today. So copy very fast. Elena, done. Okay, Mbanude, done. Ezocha, done. Bonaya, done. Osoko Okechukwu, done. Maria Okorocha, done. Okay, so let me explain. Number two, the first one we did was electrolyte, and I've explained that. Number two is electrode. Electrode are materials in the form of a rod or plate through which current enters or leaves the electrolyte. Let me go again. Electrode are materials in the form of a rod or plate through which current enters or leaves the electrolyte. Now, we have two types of electrode. There are two. One is the anode. Anode is a positive electrode through which current enters the electrolyte. Number two, cathode. Cathode is a negative electrode through which liquid leaves the electrolyte. Let me explain. This must be in form of what? A rod or plate for it to be classified as electrolyte. And once it is classified as electrolyte, in a system, we must have anode and what? Cathode, right? Now, the current enters through the electrolyte, through the what? Through the anode, and leaves the electrolyte through the what? Through the cathode. I'm going to draw a sketch that contains all of that to see what an anode, cathode, and the electrolyte itself. Okay? So the next thing I'm going to look at is what to say to be is a cell called voltameter. All right? So let's see what is voltameter. Okay, so I can clean the board now. Charity, cardio, you are done. Okay, that's good. I can clean the board now, right? So let's go to the next one. Jembel, are you done? Jenny, you're wasting much time. Okay, Ephraim George, why did I use liquid in the second one instead of current? Current and liquid is still the same. I can still decide to use current, okay? I can still decide to use current in the second one. We are saying the same thing. and we mean the same thing. Okay? Is that okay? I can decide to use liquid in the second one, it's still the same. When current enters through here, it still leaves through the other one. It's still the same. Okay? Amanda, yes, it is studying. Studying. Thank you for that. Okay, look, you're a commerce student. A commerce, okay. Well done. Okay, this class is for science students. Are we done so that I can explain? Eliana, done. Jembelo, you're not done. Charity Kalio, you are done. All right. Let me just explain. Banude done. Okay, let me explain. A voltameter is a device for studying the flow of current through a liquid. So we use this device to study the flow of what? Current. Now it consists of the following. This is a voltameter. Now, I told you that we have electrolytes, we have electrode. All are inside this device called a voltameter. Now, this is my electrolyte. This is this liquid. Remember, it must be a liquid or molten form, right? And we have two electrodes. See our what? Anode. Anode is a positive electrode. Cathode is a negative electrode. Okay? Now, this anode that is a positive electrode is going to attract only a negative ions to itself, okay, because of attraction. During ionization, okay, or during an ionization, it's going to dissociate into the electrolyte is going to dissociate into ions, and the negative ions will go to the anode, while the positive ions will go to the what? To the cathode. Do we understand? But I'm going to explain that concept again. But all these things are under what? Voltameter. We use this device to study the effects and the movement of current through and out of what? Electrolysis. Do we understand? Okay. Yes, Ezocha. The cathode is to battery supply, yes. It's to battery supply. Okay. Do you understand? The cathode is to battery supply. Chukwemeka, you are not through, okay? Terminal Grace, you are done. Harley, you are done. Okay, just be fast so that we can proceed. We have a lot of things to discuss today. Okay, Ephraim George, what I mean by to battery supply is that it is connected to the battery source. Okay, it is connected to the battery source. For example, we have a cell of a battery. We have a cell of a battery end. A battery end, like a symbol for a cell or a battery, is like this. Okay, this one is positive. This is connected to what? Negative. Why this anode is connected to what? Positive. Do we understand? So negative is to negative and positive is to what? Positive. Okay, you understand now. All right. So we can proceed. Chukwemeka, you are done. All right. So let's proceed. Obona, you are done. I see you. Let's proceed. Balude, can you give me an example of an anode or cathode? Okay, I'm coming. I will do that. Let me just explain it with this diagram. Okay, Chukwemeka, I say you don't understand this voltameter. All right, I'm going to use that diagram on the board to explain more on the voltameter. Okay, the down is the voltameter, but the up part is like having a cell, everything, key, rheostat, everything about a cell on top of it. So I'm going to use it to explain that voltameter. Do you understand? Okay. Okay, are we done? I want to start explaining. If you are just coming, don't forget to subscribe and double tap on your screen. Okay. Yes. Jessica, I did not forget. I will answer it with that diagram on the board. Jembelo, you are not done. Okay, let me explain. Okay, I'll wait for those people that are still writing. This is a voltmeter, okay? And we use this voltmeter to study the flow of current through a liquid. Now, let me leave this and explain this voltmeter for my student that say does not understand the concept of this voltmeter. This voltmeter is a device that has anode, cathode, and electrode. These are electrodes. It has anode, cathode, and electrolytes. Okay. So this is my anode. This is my cathode. Why this is my electrolyte? What is the electrolyte there? Electrolyte is the liquid or molten form inside this voltmeter. Now we have anode, and anode is a positive electrode. We have cathode, and cathode is a negative electrode. Now, how does this dissociation of ions occur? That is what I want to explain. This is a cell, and this cell, a cell is a battery. Now, this is what? Positive and what? Negative. This is positive, so it will be connected to the positive end of the cathode, of the anode, sorry. The positive terminal of the cell will be connected to the positive end of what? To the end of the anode, because anode is positive. Then the negative terminal of the cell will be connected to the what? To the end of the cathode, because cathode is a negative electrode. So in electricity general, we connect negative to negative and positive to positive. Don't forget that. We connect negative to negative and positive to positive. So with that being said, this is a key. A key is a device that we use to open or close our what? Circuit. If I want current to flow, I'm going to close the key and current will do what? Flow. If I want to end the circuit or to cut the circuit, I'm going to open the key, so that current will no longer flow. The rheostat uses to vary the resistance flowing in the circuit. Rheostat, okay, uses to vary the amount of resistance in the circuit. All right, then coming to this, I want to explain more on this dissociation of ions. And we have electrolyte. For example, you said that electrolyte will be solutions of acid, bases, and salt. Let me assume to use this as electrolyte. If I use H2SO4 as an electrolyte, now if this electrolyte should dissociate into ions, I'm going to have 2H plus and SO4 2 minus. Am I correct? Okay, so if that is the case, now this is what? This is what we call cations. Let me write it where you understand it. And this one is what? This is cations. Positive charges are called cations. Positive ions are called cations. Negative ions are called anions. Now, if we have that, these cations will go towards what? The cathode. Why is it going towards the cathode? Because of what? Attraction. Because of attraction. Positive and negative will attract. That is why these positive are going towards this what? This cathode. Okay? And then these anions, they are negative. They are going to go towards what? The anode. Because anode is a positive electrode. So that positive and negative can do what? Attract. Do we understand? Then the work of the cathode is to collect or to receive all negative ions, while the work of the anode is to receive all positive ions. I hope you understand. Okay. Okay, Joel, I've explained rheostat. Use rheostat to measure the amount of resistance in a circuit. We use it to vary it. It can be varied. Rheostat can be varied. It's not close by, but I've shown what is a rheostat. Let me check. Okay, now this is a rheostat. Can you see it? This is a rheostat, okay? We can use this rheostat to measure the amount of resistance in the particular circuit, okay? We can adjust it, okay? And we adjust it. That's just work of rheostat. This is a rheostat. use it to, we connect this the end, you open it and connect to this end, then you open here and connect to this end. That is how it is connected. Okay, so this symbol that is here is for what? It's a rheostat. Do we understand? Okay. Now let me explain again. I said during the dissociation of ions in this voltameter, what happens? All the ions in the electrolyte is going to dissociate. Now this is going to dissociate. I used H2SO4 to explain that concept. Then if you dissociate, I'm going to have, this will separate cations and what? Anions. Positive ions are called cations. Negative ions are called anions. Now these cations will move to the cathode. Why are they moving to the cathode? Because cathode is a negative electrode. Remember, in this attraction we have positive and negative will come together for attraction to take place in electric current, in electric cell. Okay, so this cathode going to the cathode because they are what? They are negative electrode, so that they can attract them. Now this anions is going to be what? Anode, because anode is a positive electrode, so that it can attract them. Do we understand? Now when they get to the cathode, now we now have that cations or ions that are based on the preferential discharge in the electrochemical series, and also based on the position of the ions in the electrochemical series. We are going to know the ions that will truly be discharged at the cathode and the one that will remain. That's not what I'm saying. I'm saying that once they get to the what? Cathode. And just explain with physics terms. You are going to still do it more in chemistry, but I'm using physics terms to explain. Once they get to what? To the cathode, selection will take place. Some ions that are higher or lower in the electrochemical series will be discharged, depending on the criteria. Do you understand? Then when they get to the what? To the anode, the ions that are lower or higher will be what? Will be discharged or be deposited. Systems to explain it. They are going to do it more on in chemistry. Is that okay? Okay, when I said vary, what do we mean increase or decrease? Yes, we use it to vary the resistance of this particular circuit. Let's assume it's a question. Let's assume it's a practical work. They're going to give you the resistance, or they can ask you to find your no resistance. So that is why we certainly use this rheostat to vary the resistance. That is why it is there. It can be adjusted. It can be adjusted to get a fixed point that you are required to get. Okay? All right. So I don't know if you understand this explanation on the board. If you understand it, you let me know. I just explain it on the basis of physics. What is a rheostat? Look at a rheostat. Come on, this is a rheostat, okay? This is a rheostat. We can connect it here and connect it here. So we use it to vary the resistance of a particular circuit. All right. Okay. Harley, your signal is breaking. Maybe you should change your position. Maybe it's network. So network is bad. Okay, now, so can we proceed? The signal is breaking. Can you? Is it okay now? Okay, so Kwekechukwu is okay now. Thank God. Jembelo, are you done? Joel, your one is still breaking. You double tap. Have you subscribed? Okay, so double tap on your screen. Somehow, okay. Understood well, ma. Terminal grace. Okay, so let's proceed. Okay. Okay, Chukwemeka, I said that the positive ions are called cations. The positive ions are called cations, while the negative ions are called anions. Jessica, I thought I've answered your question. Jessica, I thought I've answered your question. You said I should give you examples of anions and cations, right? That is the question you asked actually. Anions and cations, they are electrode. They don't have example. They are electrode. So when they are inside a voltameter, okay, the negative ions will go to the anode. Okay? Yes? The negative ions will go to the anode, while the positive ions will go to the cathode. I don't know if that has answered your question. Anode and cathode does not have example. They are electrode. They are electrode. Okay, Jessica. The positive ions will go to the cathode because cathode is a negative electrode, while the positive ions will move. The positive ions will move to the cathode, okay, while the negative ions will move to the anode. Is that understood? Jessica, do you understand? So they don't really have examples. Their work is just for them to accept ions that are coming to them. It's not an element, it's a rod or plate. If you look at the definition I gave you under electrode, they are rod or plate. Okay? They are rod or plate. It's not an element. They are rod or plate. Material that can be used for the construction. Certainly, there should be material that can be conductors now. Material that can be conducted, that can accept electrons. That's what they can use for the manufacture of anode and cathode. Okay? We can't use elements. It's either we use rod or we use plates and make one as cathode, make the other one as anode. Do you understand? Application of electrolysis is electroplating. This is the process of coating a metallic object with another metal. Process of coating a metallic object with another metal in order to improve its appearance or safeguard it against corrosion. What do I mean by that? You will get a metal and coat it with another one, right? When you coat it, that process is what is said to be what? Electroplating. Now we use these materials. We have copper, silver, chromium, nickel, gold. Can be used to electroplate other metallic objects. Do you understand? Now, let me recap. Electroplating is the process of coating a metallic object with another metal in order to improve its appearance or safeguard it against corrosion. Now, let me explain again. Most of the spoon we use that wrote stainless steel. It is not stainless steel actually. It was coated. That's the process of this electroplating. It was electroplated. If I want the color of the spoon to be silver, I will coat it with silver. Okay? If I want it to be gold, I will coat it with gold. That is why we see most of this big pot we used to cook large quantity of food. If the pot stays for a very long time, you will see that the thing will start rusting. You will not see the true color of that material used in production of that pot. Okay? What they actually do after the production of the pot is to coat it. So it will look shiny, it will look fine, and people will buy it. So that process is what is said to be what? Electroplating. Okay? Corrosion means rusting. Which type of plate? We can use any plate. We can electrocute any plate. Okay? This is just like the process of, this is a spoon. I will now coat it. That's electroplating. Let's assume it is iron, and iron, the color is always brown or dark color. To coat the spoon with silver. What I'm going to do is to keep it there and pour what? Silver on it. I'm going to explain it more. When I clean this slide, I'm going to show you what I mean by this. I want this diagram to explain. They will now coat it. It will now come out by what? Bearing a silver color. That is what we mean by electroplating. Okay? Plating is rubbing this silver on this material, it will change to silver. Or rubbing gold on this material, it will change to what? It will change to gold. That is electroplating. We are plating another color on it because that is not the true nature of it. Because I want to improve its appearance so it will look fine and safeguard it. If I leave it with its true color, it might rust. That is corrosion, meaning rusting. So I need to coat it. I need to electroplate it so it can stay for a long time and it will look fine for people to patronize, for people to buy. Okay? That's what I mean by that. If you are just joining us, Oluchi Obedience, so thank you so much for coming. Just double tap on your screen and make sure you subscribe to this channel. Are we done writing? Let's go to the next one. NECO, you're welcome. Please, are we done? Class, are we done so that we can proceed? I want to clean the board. Jembello. Jessica, are you done? So I'm still explaining electroplating. Okay, please copy fast. Let me explain. Okay, we are done. Okay, so in general, the material to be electroplated is used as the cathode of a voltmeter, which has an anode made of the electroplating material. The electrolyte used is a solution of the salt of a metal to be electroplated. What do I mean? I want to explain the concept of this electroplating. I want to electroplate this spoon. I want to change the color of this spoon. What am I going to do? I'm going to make the spoon that I want to electroplate, that I want to change its color to be the cathode, right? Then my anode will not be made of what? Of the silver, because I want to coat this spoon with silver color. So because I want to coat it with silver color, I'm going to make it the cathode, so that the silver that I'm going to use will be what? Will be my anode, so that it will coat this particular spoon. Do you understand? During electrolysis, all the electrolyte here is made up of, let me check what I have. Potassium silver cyanide solution. Okay, the electrolyte is a potassium silver cyanide solution. So the electrolyte itself is made up of what? Of potassium silver. So with this, as it is being deposited, all the silver will now go to the what? To the spoon. Because during electrolysis, it's going to dissociate into ions, and once it dissociates, it's going to, the one that will move to this cathode is going to coat this spoon, because spoon is already the cathode. Okay, and eventually it will now change to be the silver what? Color. So this is the process in which we coat most of our kitchen utensils. You see the color shining. This is the process they undergo to come out that look or that appearance. So this is a particular jam. They ask this particular question in jam. The material to be electroplated is made what? Is it cathode or anode? So it is made the anode. Okay? Is it cathode or anode? Sorry, it is made the cathode. Once it is made a cathode, now the solutions of this anode during the dissociation of ions, you now go and coat the what? The cathode, and change the particular color that you want it to be. If you want it to be silver, it will be silver. If you want it to be gold, it will be gold. So that is the process of electroplating. I don't know if you understand what I explained. Power and redemption, you're welcome. Thank you for coming. Okay, do we have questions? I want to move into other applications of electrolysis. You're welcome. Please double tap on the screen. Thank you so much for coming. It will not lose its silver color. It will not lose its silver color because electrolyte is a liquid. Electrolyte is a liquid, so once it is coated, the whole of the system is made of silver, because the essence of using potassium silver cyanide solution is to make sure that we coat that spoon to be silver. But if you still want it to, if you want to coat it gold, we can still use electrolyte that's made up of gold. Okay, so we can actually coat the material as gold. Thank you, Power and Redemption. I really appreciate. Please, class, are we done writing? Are we done writing? I want to go to the next application of electrolysis. Thank you so much, Power and Redemption. I really appreciate for stopping by. All right, so I can proceed. Okay, number 2 application, we have calibration of an ammeter. We have number 3, the purification of impure metal. And number 4, electrolytic production Okay, let me explain. We have the next application of electrolysis. Number 2 is the calibration of an ammeter. We use electrolysis to calibrate an ammeter. Number 3, the purification of impure metals. And number 4, the electrolytic production of metals from their compounds. So, but the main one that I explained clearly is this electroplating. And that is what the examiners normally bring out in external exams, okay? So take down all this. Let's dive into the laws of electrolysis. Please copy fast. Please, are we done? We are done. Okay, so let's go to laws of electrolysis. What are these laws of electrolysis? Let's take the first law. Okay, the class will end by 6. I have few minutes to go, so just hold on. Let me just explain this first law and solve problem on it. If you are just coming, just give it a thumbs up. Double tap on your screen. Okay, let me explain. Faraday's first law states that we have Faraday's laws of electrolysis. So I'm going to explain first law today. Faraday's first law states that the mass M of a substance liberated in electrolysis is directly proportional to the quantity of electricity Q which has passed through the electrolyte. You understand? The mass liberated in electrolysis is directly proportional to the quantity of electricity. Directly proportional to the quantity of electricity which has passed through the electrolyte. That is what Faraday's first law states. Now, if I want to explain it further, remember, in any proportionality sign, you have to remove its proportionality sign and introduce a constant. Okay? But what is Q? Quantity of charge. We all know that quantity of charge is current times time. Okay? So if I replace it here, I have my M is now proportional to the current times what? Time. But when I remove this proportionality, I'm going to introduce a constant. So I have M is equals to ZIT. What is this constant called? It is called electrochemical equivalent. M is for mass. Z is for electrochemical equivalent. I is for current. YT is for time. Do we understand? I'm going to explain it further. Okay, I should proceed. Are we done writing? Are we done? Class, please, are we done? We have 10 minutes to go, so I can conclude today's class. We'll continue tomorrow. Okora and for Maria, you are done. Okay. Charity Kalio done. Drill done. Okay, let me proceed. Okay, from first law, mass is equal to ZIT. I want to derive another formula. This is equation 1 that we can also use to solve problem on electrolysis. Now, if I want to make mass the subject, I'll say cross multiply is equal to density what? Volume, right? Now, if I replace it here, but we still remember that volume is equal to area times thickness. I can use it as height. I can use D. Okay? Now, if I place it here, therefore, mass is equal to density. I'm replacing my volume with this. Area times. Do we understand? So the essence is to generate another formula for this mass and replace it with this to get another formula from solving Faraday's first law. So I have density area times height is equals to ZIT. That is equation 2. Now we can use this equation to solve problem on Faraday's first law of electrolysis, where rho is density, A is area, H I can use it as thickness, Z electrochemical equivalent, I is current, and T is time. Now let me explain. I said from first law, M is equal to ZIT. Okay, I want to generate another unit for this mass. If I remember that from density is equal to mass over volume, then I want to make this mass the subject. I will not say cross multiply by saying mass times 1 is mass, density times volume is density volume. Okay, so I'm replacing this mass with density volume. And also, I should remember that volume is area times what? Height. And my height here is classified as the thickness. Now, if that is the case, I'm going to replace this mass here to be density times area times thickness. Okay? Then going by that, this is my equation 1, but here my mass is replaced to be what? Density times area times thickness is equal to ZIT. All right? Where rho is my density, A is area, H is thickness, Z is electrochemical equivalent, I is current, and T is what? Time. I hope you understand that. Okay, class, you can copy fast. I want to end the class right now. It's almost 2 hours. I want to end it now. So tomorrow we are going to solve all the problems. Come prepared with your calculator. There is class tomorrow. Chukwuemeka, there is class tomorrow. I'm going to tell you the time on the group night. Okay? T is time. There is no capital T. This is there is no capital T. This is I. This is I. I is for current. T is time. Okay? There is no capital T here. It's small t that we have. Under density, I have area, capital A as area, then H as thickness. Please, if you have not subscribed to this channel, don't forget to subscribe and give it a thumbs up. Before density, are you sure it's not from your network? Before density, I wrote where. Okay. This is not capital T. I said over 1. Like over 1. Eh? And I did cross multiply. Okay? Over 1, cross multiply. So that mass will multiply 1 to get what? Mass. Density multiply volume to get density volume. Okay? Okay, I just explained, yes. It's cross multiply that I did. Cross multiply, mass multiply by 1, I get mass. Density multiply by volume, you get density volume. Are we done writing? Yes, it's not capital T, but roll over 1. Yes, I just corrected it. Jembelo, you are done. Okay, are we all done? Are we all done? Carrie's Kitchen, thank you so much for coming. Okay, Maria Okrafo, you understood perfectly, okay? Okay, support, okay, thank you so much. Drea, we are done. Okay, are we all done? We are going to meet tomorrow. Carrie's Kitchen, thank you so much. Please double tap on the screen. Thank you so much. We are going to meet tomorrow to solve calculations on electrolysis, so don't miss out. Thank you so much. I just saw it, Carrie's Kitchen, I appreciate. We are going to solve calculations on electrolysis, so don't miss out tomorrow's class. I'm going to send the time for you so that you can follow us and join the class. Okay, Carrie's Kitchen, wanted to give your child the phone to follow up. Your child is in which class, please? She's in which class? I have different time for different classes. I need to know the class in which your child is. SS2. SS2, SS2. Okay. When I rearrange the time, I will tell you, I will send it to you on your channel, okay? I will send you a notification when I arrange the time this evening, this night rather. I will show you. Let me just write it down. Albana, hi. Thank you so much for coming. I really appreciate. Hello, you are welcome. Grace Tamona, you are welcome. All right. Carrie's Kitchen, I will do that. Okay, we are going to end the class now to continue tomorrow. Okay, thank you so much for coming. I really appreciate your time. Stay tuned. We are going to meet again tomorrow to learn more on physics. See you next time in my next class. Bye.